Maths Masterclass with Leo. Let me teach you a bit of math.
Okay?
In this channel, we'll be dealing with learners who are in grade 10, grade 11 and grade 12. We'll be dealing with learners who are below average, average and above average. Actually, when you talk about learners who are below average, you're talking about from level 1 to level 3 learners. Average, you're talking about level 3 to level 4. And then above average, you're talking about level 5 to level 7. We'll also be dealing with learners who want to rewrite maths. They've been struggling with maths. And then we'll be dealing with ways to answer questions, how to attempt questions, how to actually pass maths. And then we'll be dealing with question papers, paper 1 and paper 2. You know those simple chapters in paper 1 when you talk about the average learners or below average learners. You know those questions. And then when you talk about paper 2, you know those questions, you know those chapters, statistics, and so forth and so on. Good day. Welcome to Maths Masterclass with Leo. I'm Leo, and today we're doing exponents and surds. As much as they are simple, they make a very big part of our maths, especially when you talk about algebra. And remember, algebra, it contributes from 25 to 27 marks in your paper 1 exam, right? In this case, let me just do a simple introduction to this so that everyone is calm. I'm just going to do this one, which is square root of 8 multiplied by 2, which is multiplied by square root of 2. This is simplify, which are simplify. What are we simplifying? We're simplifying this surds. I'm going to do 2 questions from surds, and then I'm going to do we're gonna go to exponents, right? So in this case, we're given something like that. These are surds, right? They say simplify that. What are we gonna do? You're just gonna say square root of 8 multiplied by 2, right? This will give you square root of 16, right? This will give you the square root of 16. This is just a perfect square. This will just give you 4, right? And then you're given another question, which is question 2, which is cube root of 4 multiplied by cube root of 2. It's a similar question. You're just gonna say cube root 4 multiplied by 2. This will just give you the cube root of 8. This is just 2. Then you can just take one more question from this question 3, which is just given it's 9 plus square root of 45 all over 3, right? How am I gonna do that? I'm just gonna say I'll have this is just square root. I'm gonna have 9 plus this is just gonna be square root of what? Okay, I can just say okay, it's just gonna say 9 or 45 divided by 9. I'm just gonna say 45 divided by 9. I'm gonna have 9 multiplied by 45, multiplied by 5 in this case. This will give me 45 all over 3, right? I'm just gonna say this will give me 9 plus square root of 9 multiplied square root of 5, right? Very simple. Then divide by 3. Then this is just gonna give me 9 plus this is gonna be this will give me what you call 3 multiplied by this will give me square root of 5, right? All over 3. Don't forget. In this case, I'm just gonna say what is my common factor? My common factor is 3. Why do I take out the common factor? I have plus and then I have this 3, which is part of this 5. It's a product of this 5. So I'm just gonna say 3 into what is 3? 9 divided by 3 is gonna give me 3 plus square root of 5 all over 3. When I say 3 multiplied by 3 is going to give me 9. 3 multiplied by square root of 5 is going to give me 3 multiplied by square root of 5. And then this 3 and this 3 will just cancel each other. I'm going to left with 3 plus square root of 5. Very clean. Now, let's go to exponents. Let's go to exponents. Exponents. Okay. We're given basic exponents rule. Basic exponents rule. Just know that if you have common base, you have a multiplied by a to the power n plus, or multiplied by, actually not plus, a to the power m, right? if you're given something like this, okay, I'm given something like this, they say common base rule, this is just gonna give me a to the power n plus m. And then the second one, where it says a to the power n divided by a to the power m. This can be written as, it's one and the same thing when you write it like this, right? This will just give me a to the power n subtract m, right? Then let's just take a question, then try to use this rule to answer the question, right? I'm given a question that says, I'm given a 27, okay, to the power 3 minus 2x multiplied by 9 to the power x minus 1 all over 81 to the power 2 minus x, right? How am I going to do this question? How am I going to attempt this question? I'm going to use this rule, or these rules actually, not just this one, but both of them, right? Then I'll have, but first, how can I make these things common? How can I make these things common? I can make them common by saying, okay, let's change this 27 into exponents. How can I change 27 into exponents? 27 can be written as 3 to the power 3. This will just give me 27. And again, 9 can be written in terms of exponents, which is 3 to the power 2. And again, 81 can be written in terms of exponents, which is 3 to the power 4. Right? Then I come here, I can just say, instead of writing 27, I can write this and say 3 to the power 3 into 3 minus 2x multiply. Instead of saying 9, I can just say 3 to the power 2 into x minus 1. Instead of saying 81, I can just say 3 to the power 4 into 2 minus x, right? And then, again, okay, what do I do? This exponents will just multiply everything inside the bracket. I'm going to have 3 to the power 3 multiplied by 3 is going to give me 9. 3 multiplied by negative 2x is going to give me negative 6x multiplied by 3 to the power 2 multiplied by x, it will be 2x. 2 multiplied by negative 2, it will be negative 2 multiplied by negative 1, it's negative 2 actually. Then divide by 3 to the power 4 multiplied by 2, it's going to be 8. 4 multiplied by negative x is going to be negative 4x. This will just give me like that. Okay, now I have common bases. Let's start with, remember the BODMAS rule says, okay, it's BODMAS. We deal with the, let's just deal with the numeric, the numerator, then we'll just deal with the, the denominator afterwards, right? Then now I'm going to have 3 to the power, okay, 9 minus 6x, because of the first rule. The first rule says, if we have a multiplication sign, and the bases are the same, we can add the exponents. I'll add plus 2x minus 2 all over, this one we write it as it is, minus 4x. This will give me, now I'm going to have 9 minus 2, this will give me 9 minus 2, it's going to be 7. Negative 6x plus 2x, this will give me negative 4x all over 3 to the power 8 minus 4x. Then we move, okay, let me just take it to the other side. In this case, I'm going to take it to the other side, which I'm going to have 3 to the power 7 minus 4x. It's just a repetition. I'm just taking everything that I wrote on the other side, write it here so that everyone can see, right? And then I have common base again. The common base rule says when I have a division, I have a division like this, I'm going to have something like this, right? So let's apply that rule. I'm going to have 3 to the power 7 minus 4x minus, don't forget the bracket, because of the negative, you need to include the bracket, minus 4x. It's like that. I'm going to have 3 to the power 7 minus 4x minus 8 plus 4x, right? And then if you can see, we have a negative and a positive. Minus 4 plus 4, or 4 minus 4 is going to be 0. This will, and this will just cancel. I'm just going to have, okay, 3 to the power 7 minus 8. 7 minus 8, what is 7 minus 8? It's going to be negative 1. and this can just be written as that, and then you can just write it as that if you wanna conclude it. Now we have simplified our equation, our expression. We cannot say it's an equation because it does not have an equal sign. It's an expression. Very clear. Then let's go to the next question. It's still simplifying the the expression. We have 6 multiplied by 5x to the power of 5 to the power x plus 1 minus 2 multiplied by 5, okay, x plus 2 all over 5 to the power x plus 3. Okay, we are given another question that says 6 multiplied by 5 to the power x plus 1 minus 2 multiplied by 5 to the power x plus 2 all over 5 to the power x plus 3. So in this case, a very simple mistake that students do, is they will multiply 6 and 5. That's very wrong. That's very, very wrong. You cannot say 6 multiplied by this. You cannot say 2 multiplied by this. Once you do that, you are very wrong because you are trying to multiply things that are not the same, right? This is a whole number. This is an exponential expression. Once you multiply an exponential expression and a whole number, it's gonna be wrong. What you have to do in this case, you have 6. Break this. How do I break that? I'm gonna have 6 multiplied by 5 to the power x multiplied by 5 to the power 1. I'm reversing this rule. I'm reversing which rule am I reversing? I'm reversing this rule that says, okay, that says a to the power n multiplied by a to the power m equals to a to the power n plus 1. Plus m actually, not plus 1. Ne? So in this case, I have this part. I have the final answer, which is 5x plus 1. Reverse it. I'm going to have 5 to the power x multiplied by 5 to the power 1. I hope you understand. Jesus, my thing will be messed up. Okay, sorry. I'm just going to say here 2. Again, reverse it. Multiply by 5 to the power x multiplied by 5 to the power 2. I'm sorry with this. Right? Okay. All divided by, I'm going to have 5 multiplied by x multiplied by 5 to the power 3. Right? In this case, if you can check, you have 5 to the power x, you have 5 to the power x, you have 5 to the power x. Common, very common. So I'm going to say, take out 5 to the power x, I'm going to have 5 to the power x, then bracket, I'm going to have, this is 6 multiplied by, here I'm going to have 1 multiplied by 5 to the power 1. If you have a problem, you can just leave your comment below, then I'll address your problem. Minus 2 multiplied by 1 multiplied by 5 to the power 2. Very clean. Divide by 5 to the power x multiplied by 5 to the power 3. Right? If you can check, this and this, they'll just cancel. This and this just cancel. I'm going to have 6 multiplied by 1 multiplied by 5. This will just give me 30. Subtract 5. Okay, this is minus 2. 5 to the power 2, it's 25. 25 multiplied by minus 2 is going to be minus 50. You can just use your calculator here. And then this is just going to give you 125, right? Then this is will just be, okay, this is going to be 20 divided by 125. Then what is 20 divided by 125? What is 20 divided by 125? We have 4 over 25. Now, actually this is supposed to be negative. This is supposed to be negative because 30 minus 50 is going to be negative 20. So I'm going to have negative 4 over 25, right? Let's move to the next question. Our next question says that we're given 2 to the power 2009 minus 2 to the power 2012 divided by 2 to the power 2010. Oh, how am I going to do such a question? I have no idea. How am I going to do such a question? You cannot say, because in this case you don't have a multiplication sign. Don't say this is the rule that says multiplication, that says multiply actually. If you use that rule, you are out. You are out of order. Then now, you are given something like this. They say simplify this. What are you going to do? Okay, in my point of view, I need to make everything to the power 2009, right? I'm just going to have 2 to the power 2009, subtract 2 to the power 2009 plus, okay, from 2009 to 2012 I have 3, right? All over 2 to the power 2009, from 2009 to 2010 I have 1, right? I'm just splitting this so that everything is similar to, or so that everything has or contributes of, it has what you call 2009, right? I'm just gonna have 2 to the power 2009 minus 2 to the power 2009. Now we use that rule again. This rule is very important. We use this rule again. Multiply by a to the power m equals to a to the power n plus m. We reverse this rule. Because we have, you see, in this case we have 2009 to the power, 2 to the power 2009 plus 3. So we're gonna reverse it. It will give us 2 to the power 2009 multiplied by 2 to the power 3. Very true. Divide by, okay, we reverse this one as well. It's gonna be 2 to the power 2009 multiplied by 2 to the power 1, right? And then we're just gonna say 2 to the power 2009 is a common factor. 2 to the power 2009 into, here I'm going to have 1 minus 2 to the power 3, right? All divided by 2 to the power 2009 into 2 to the power 1, right? This one and this one will cancel. I'm going to have 1 minus that, which will give me minus, okay, it's going to be minus 7, because, okay, let's just write it in full. It's going to be into 1 minus 8 all over 2. Then this will give me minus 7 over 2. Clean.